Welcome to Examrace. So today's physics topic is central force. We will continue with the central force today. This is the important topic. Every year you can see the question in various exams in NET, GATE, TIFR, JEST. In every exam you can see that the question from central force is common, and that's very important topic. So as per the see the problem of central force or finding the motion of particle of central force is one of the most common problem and asked in every exam of physics because it is closely related to the motion of particle around the other particle, motion of satellites around the earth, motion of earth and other planets around the sun. So central force is most important for this concept. Central force is always directly toward or away from the center because the particle is moving around that center. So either it is forces toward the center or away from the center, and it is a vector quantity. But here we are dealing with the equation of motion, central force motion. So what actually it is? This equation is also known as equation of orbit. So this is a differential equation of orbit for central forces. So what it is? It is d2u over d theta square plus u is equals to m upon l square u square f1 by u, where u is the r is the distance between the fixed point and the point where the orbit is exist, means the fixed point is this and a point passing through that orbit. Okay, so this is what, this is r, this is r. So u is actually not r, it is 1 by r, u is 1 by r, and l is the mass of that object. Sorry, no, m is the mass of that object, m is the mass. And what about l? L is the angular momentum, not angular, it is a moment, it is angular momentum or moment of momentum. Moment of momentum is what angular momentum is. Okay, momentum. Okay, now regarding this, what type of questions are asked? So let's take a question. This question is regarding that a particle is moving in 2D and in an orbit, and that orbit relation with that angle is given, means distance relation with that angle, and it has some central potential, and central potential is also given, and you have to find the constants A and B. So this question is actually central potential, means central force motion is involved, and how to use that equation. That equation is d2u upon d theta square equals to, sorry, plus u equals to f of 1 by u upon l square u square into m. Okay, so this is the equation of central potential, and minus sign is also there. Clear? Now what is u? What is u here? u is 1 by r. So to satisfy this equation, I have to find d2u upon d theta square. But u is in terms of r. Where is theta? Theta is from this, because the orbit distance is in terms of theta. So what is r? R is 1 by r naught theta square. Okay, so u is 1 by r naught theta square. So if I want to find du upon d theta, it will be minus 2 upon r naught theta cube. And similarly, if I want to find d2u upon d theta square, which is equals to 6 upon r naught theta to the power 4, and u is in terms of theta. Just put the values and try to get the next step. So what is the value of d2u upon d theta square? It was 6 upon r naught theta 4. What was u? U was 1 by r naught theta. Just put the value. So it was d2u upon, so it is 6 r naught theta to the power 4 plus u. U is 1 by r naught theta square is equals to minus f1 by u. Just take it as sim. Instead of 1 by u, we can write 1 by r. Instead of 1 by u, we will just write r, because this equation is in terms of r. And next step was m upon l square into u square. So u square is r naught square theta to the power 4. Is this okay up to now? Now if I want to find is simply f by r. What will be the f by r from here? Just solve it and we will get the value. Just try to multiply with the l square and divide with minus m r naught square theta to the power 4. It will be 6 l square upon m r naught cube into theta to the power 8. Again minus l square upon m r naught cube theta to the power 6. Now we know r, because this is this function is in terms of r, but here the function is not in terms of r, it is in terms of theta. So I have to convert, means r is what? R naught theta square. So wherever r naught theta square came, I just replace it by r. Here you can see this is r naught cube. If I multiply r naught and r naught in numerator and denominator both sides, this will become r naught to the power 4 theta 8, and this simply remain the same. So the equation will become fr is equals to minus 6 l square r naught upon m r naught theta square to the power 4 minus l square upon m r not theta to the power 2 into to the power 3. Okay, so what we can see here, r naught theta square is r. So if I replace it, it will become minus 6 l square r naught upon m r to the power 4. Similarly, l square upon m r to the power 3. And these are just constants. These are just constants. So if I replace them by constant, it will become minus a r to the power minus 4 minus b r to the power minus 3. Now what is potential? Potential energy is FR dr. You all know this. So what will be the V? V is just integrated. So it will be, and adjust with the minus sign, it will be R dr plus B R, this is minus sign, minus 3 dr, and which is equals to A by, which is equals to so A by minus 3 r to the power minus 3 plus B by minus 2 r to the power minus 2. So if you compare with the given equation, that was V C1 constant, the equation given is this: A plus C2 constant B. So A is 3 and B is 2. This question was asked in previous year 2021, where the question was to find the values of A and B. So in this way we can find the value of A and B. Thank you. For more and for complete course and subscription, visit to www.doorsteptutor.com. Thank you.